Picture a place where even light cannot find an escape route. Not because physics breaks, but because space-time bends so sharply that every possible future leads inward. That boundary is called the event horizon, and crossing it is like crossing a final one-way gate. Black holes form when a massive star exhausts its fuel and collapses under its own gravity. Its core falls inward with no remaining force strong enough to resist. If enough mass is packed into a tiny region, the collapse doesn't halt at a dense object. It keeps going, forming a black hole. From the outside, the collapse looks odd. Clocks near the forming horizon slow dramatically, and light coming from the region reddens until it fades. Yet from the falling material's perspective, it crosses the boundary in a perfectly normal amount of time. Different viewpoints, but the same physics. Once formed, black holes are surprisingly simple. Their identities are set mainly by mass and spin, which determine how large the horizon is and how space-time twists around it. Different origins can lead to nearly identical final objects. We don't see inside them, but we see their appetite. Matter spirals inward, forming a blazing accretion disk. Magnetic fields can fling out narrow jets, blasting material across thousands of light years, and they leave solid clues. Stars near the Milky Way's center whip around an invisible object millions of times the sun's mass. And in another galaxy, a global network of telescopes captured a glowing ring around a dark shadow, the expected silhouette of a black hole. Black holes merge too. When they collide, space-time vibrates, sending out gravitational waves that detectors on Earth can measure as tiny pulses of stretching and squeezing. What should you carry forward? A black hole isn't a tear in reality. It's a region where gravity's logic reaches an extreme. We know they exist because the universe lets us see their footprints in motion, light, and space-time itself.